Good morning. Here in lesson 2, we're looking at how do we interpret a scatter plot once we have it. Again, we know that when we're looking at data, whether that's a graph or whether that's a numerical summary, the things that we're looking for our CUS acronym. We want to know what is the center, what is the general trend in the center of our data. Are there any unusual points? And we've been calling those outliers. What is the overall shape and what is the overall spread of the data that we're looking at? Now, when we're looking at scatter plots specifically, that translates into a couple of main things. The first one that we have here is going to show us a couple things that we can interpret based off of scatter plots. And that is, when I'm looking at this, my trend is that my pattern's going up. I see that as I go to the right, my points go up, and that's called a positive relationship or association or a positive correlation, you might hear it called. And that just means that as one increases, the other increases as well. They're not offsetting each other, but they're both increasing together or both decreasing together. And that's talking about the direction of our pattern here, that it is increasing and it's positive. That's the direction of graph number 1. If I look at graph number 2, the direction isn't really there. The points are all over the place. It doesn't really have a clear-cut direction. In fact, this would be something where you would see this, the association between the two is that there is no correlation. There's no relationship between the two. This would be if I gave you the example of the number of hamburgers eaten in a day and the number of, baseball tickets sold in a day. Those two are probably not going to be related on a given day in a given city. Now, they might be, but it's probably going to look more like this. It's going to be all over the place. This is also going to be an example of it's no correlation because it has very, very small strength of a correlation. Whereas graph number 3, yes, it's a negative association because it's going down. But graph number 3 shows us a very strong association. This would be something where it is a strong correlation or strong association. We see the points are all together right around what we would imagine is our trend. Our trend is going downward, but the points are all right next to each other. If I look between graph number 3 and graph number 1, graph number 3 would be a strong correlation, and graph number 1 is a moderately strong. I mean, you can see that there is a trend, and so it's a lot stronger than number 2, but the strongest of these would be number 3 that we have here. The last thing I want to show us on graph number 3 is that we do have an outlier. Now, it's tempting to look at it and say that this point on the bottom right is our outlier because it's the farthest away from all of them. The thing is, if I actually look at my trend and follow it with a line going down the middle, that point is actually part of my trend. It doesn't fight against the trend. It doesn't leave the trend. It's actually right on line with what I would expect it to be. Now, this person may be an outlier. If this is height and, bone structure. I mean, if it's some sort of thing where we're looking at this person and it's, obviously they are a lot farther away from our data, but it hits the trend, and so it's not an outlier. An outlier in this one is going to be our point that is below and to the left of our trend. It's not as far away from our data points as our point to the bottom right is, but it is away from the trend line. It is a little bit away from the actual trend that we have here. And so I'm looking at that. That's how we're going to be determining outliers. It's not distance from the group, but distance from the trend. And that's a little bit different from what we've been doing before. The last thing I want to talk about is rather than just plotting all these points by hand, because it can take a while, we're going to talk about how would we plot and look at these sorts of graphs by using technology, by using our graphing calculators. And so what I did is I posted a couple of pictures. They're actually from our textbook about how do we use our calculator to find all of these. And those steps that we have are this. Because we're looking at the relationship between two separate variables, when I go to my list, I'm going to enter in list 1 and list 2 as like an XY column, an XY chart that we have there. Our first one, if it is an explanatory variable, is going to be our X value. Our second one will be our Y. They don't have to be related that way, but if it is, put the explanatory variable first. And you enter all of that in into L1 and L2. The example that's in our book, and I would like you to find some data and practice with this. Maybe on our homework you'll find some data. Practice putting this into your calculator by following these steps. Once you have the data in, the way that we graph this is we're going to look at our stat plot. Now, stat plot is right above your y equals button on the TI-84 calculators. And so what you would do is you would hit second and then equal to find your stat plot. Once you're there, you're given a large list of plots, and you can just select the first one, plot 1, and then you adjust your settings to the picture that we have there. You want your graph to be on. You want the type to be a scatter plot, so you want it to look like the little dots that we have there. Your X list is your first list, which is your horizontal axis, your explanatory variable, and you want that to be your L1. That's why we enter that in first. Your Y value would be L2. By the way, I could switch those, and I could still graph them, but if we always enter in X in L1 and Y in L2, we don't have to worry about it here. And then for the mark, I would use the biggest mark. It's going to be a little bit easier to see on your calculators than the small one would. After that, we want to look at where the graph is actually taking us. We don't want to look at a graph that is all our information's here in the middle, and we're looking at a graph that's down here only. We want to look actually where our data is plot. And so in order for you to do that, the zoom stat button, which is zoom and then the 9th option down, actually gives you the data that is right there where you need it to be. That's the way you would look at the graph. There's more things that we'll talk about on our graphing calculators later, but now we have an ability to, if I've got a list of data, to put it on our graphing calculator to see what it actually looks like, and then we can determine what is the strength, how close our points are together, what is the direction, is it going up or is it going down, and what are some outliers or unusual points that may have, points that may be away from the overall trend. Those are the things we're focusing on here, and that will be on our homework, and that is what we're going to be focusing on here for lesson 2.